Hello guys, how are you? Hopefully you will be fine. Today we are doing a new video on A-level physics, equation of motions. So we know that there are four equations of motions. Uh, uh, Consider an object of mass m moving with initial velocity u and after time t, when the time t is paused, then its speed will become v. We know that any objects move when some forces apply on it. Due to this force, the acceleration is produced in it, and cover or displacement is denoted by s. Here we know that we represent s is the displacement and its SI unit is meter. So SI unit of distance is meter. We also know that here u is the initial velocity or the starting velocity of the object or moving object. So it is measured in meter per second. V is the final velocity, also measured in meter per second. A is the accelerations produced due to force F, is meter per second square, and t is the time taken by the object from velocity u to v. So in equations of motions, one thing remember that in all equations of motion there is constant acceleration. So when we will discuss equations of motions, then we must have constant acceleration. Sometimes these equations of motions are called SUVAT equations because S stands for displacement, U stands for initial velocity, V stands for final velocity, and A stands for acceleration, and T stands for time taken. So we can write S U V A T. So we can write SUVAT equations or equations of motions. So we discuss about SUVT equations. There are four equations given below. V is equal to u plus at. Second equation is S is equal to half u plus v, mean initial velocity plus final velocity into time taken by the object, where s is the distance, which is equal to u plus 3 u time t plus half at square. Then v square is equal to u square plus 2as. So now its derivations one by one is discussed here. So first we will derive the first motions of equation. Consider an object is moving with initial velocity u, and after time t its velocity become v. which is final velocity. U is initial velocity and V is final velocity as shown in the graph below. So U is the initial velocity of the object, and objects move with velocity, initial velocity U, to final velocity V, and in time t. So we will take V, which is velocity measured in meter per second on y-axis, and t on x-axis. We know that t is time independent variable and v is time dependent variable. So we can say that v is dependent on time, but time is not dependent on v. So we just take v along y-axis and x along t along x-axis. Hopefully you got it. So we will move to what's next page. In above graph, the gradient must be equal to the acceleration of the object. So just we will calculate the value of gradient, then this gradient must be equal to the accelerations of that object. So here gradient is defined as the rate of change of velocity over rate of change of over change in time.